Good morning, everyone. I feel immense pleasure and happy to start my today's lecture on engineering thermodynamics. I am Dr. Dwivedi, professor from Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad, India. Today, I am going to take my topic, Perpetual motion machine of second kind, reversible and irreversible processes. So, as of now, we have seen the first law of thermodynamics, which says that energy is conserved, or we can say that if you give some heat, this heat can be converted to the work. But the first law of thermodynamics doesn't say about the direction of the energy flow. In a spontaneous process, energy flow will happen naturally. Like if you are in a hot zone, the heat will flow from hotter to the colder. But to make this thing from colder to hotter, it is not spontaneous. Means we need some extra work to be done. It will take some time. We have to add something in that. Then only it is possible. So the perpetual motion machine of second kind, these machines which are not possible machine, that is impossible machine, which is related to the second law of thermodynamics, those machines are called the second perpetual motion machine of second kind. And we will also discuss these topics. This is corollaries of second law of thermodynamics. Perpetual motion machine of second kind, Maxwell Demon's reversible processes, irreversible processes, factors affecting irreversibility. These topics I am going to take in today's lecture. If you see that in my previous lecture, I have discussed about statement of the Kelvin Planck, that is, it is impossible to construct any device which is sole effect is to raise the weight and transfer the heat in a single reservoir. So single reservoir you cannot transfer and it is not possible. That is the Kelvin Planck statement. If you have the engine like this, this is the sink, this is the source, this is the TH, high temperature, and this is the low temperature here, TL. It is taking the QH, it is QL, and it is giving the heat engine, and there is a work out. So the statement of the Kelvin Planck says that if this is not there, this system not possible. Okay, so that is the statement of your okay, so that is the first statement. Now I will go for the statement of the Clausius. This Clausius statement says that if you have the one low temperature zone, it is a TL. If you want to extract this heat to the high temperature zone, that is the TH, this is the source, this is the sink. If you want transfer from low to high, it is not possible without using a heat pump. This heat pump needs some work in. Without this work, we have to give some energy, then only it is possible. This is the transfer of energy is only possible when we give some external energy we provide. It is not a spontaneous. This type of things will not happen spontaneous. That we have to, this is the statement of the Clausius which we were discussed in my previous class. Here also I will again go for the Kelvin Planck statement. In fact, this I have already discussed in my previous class, so I will go this thing in a very fast way. It is impossible to construct a device that operates in a cyclic process and produces no effect other than raising of the weight. So here the raising of the weight, it means the working against the resistance, and here if it is a single reservoir, it is not possible. So that is the importance of this Kelvin Planck. Next is the Clausius statement. It is also I have explained. It is impossible to construct a device that operates in a cyclic and produces no effect other than the effective transfer of heat from low temperature body to high temperature body. This is used for the refrigeration, air conditioning and heat pump. Now I will go for a new topic which is called the corollary 1. So the corollary 1, the Clausius statement of second law of thermodynamics is the first corollary, that is, it is impossible to construct a device operating in a closed cycle that performs no effect other than the transfer of heat from a cooler to a hotter body. So we can say that the mathematical expression is, if it is Q1, this is the hot reservoir and this is the cold reservoir. So Q1 minus Q2 is equal to W. So that is the mathematical expression for the corollary 1. Corollary 2 is what? It is impossible to construct an engine operating between only two heat reservoirs which will have a higher efficiency than a reversible heat engine operating between the same two reservoirs. So if any engine is operating in a cyclic process, so the best efficiency which we can get from any engine, TH, TL, QH, here is QL, work done, work out. Okay, so it is telling that it is impossible to construct an engine operating between two heat reservoirs. This is the H and the L, which will have a higher efficiency than a reversible heat engine operating between the same temperature. It means if any heat engine is working in a reversible cycle, will give the best efficiency. In this way only the Carnot cycle was developed, and we cannot make engine more than this cycle because Carnot cycle is the working between TH and the TL, and all the processes are the reversible processes. So there is no generation of entropy, there is no losses. So no engine can perform better than the Carnot cycle. That is the corollary 2, which is, it is impossible to construct an engine operating between only two heat reservoirs which will have a higher efficiency than a reversible heat engine operating between the same two reservoirs. So within a given temperature range, high and low, TH and the TL, the cycle which is a reversible cycle will give the best efficiency. You cannot make any engine better than that. So that is the objective of this corollary 2. Now we will discuss about another thing which is called the perpetual motion machine of second kind, or PMM 2. It is called the PMM 2. So just we will see how this perpetual machine, it is a just imaginary machine. It is like a fiction. Means you take the energy from the source, again you just send to the source, and actually you are getting the work done. It is not possible. So, so what is the PMM? That is the perpetual motion machine. Certain machines are not practicable and are hypothetical. These machines not satisfy the second law of thermodynamics or other laws. These machines are called the perpetual motion machine. It's like fiction of Tom and Jerry and others. It is like your Jurassic Park. You see the movie like that. These are the perpetual motion machine. Kind of perpetual motion machine. We have the PMM of the first kind. It violates the first law of thermodynamics. Then we have the perpetual motion machine of the second kind. It violates the second law of thermodynamics. Then we have PMM of third kind, violates third law of thermodynamics. The machine that works without friction is called the perpetual motion machine of the third kind. Means without friction. Now there is no friction, everything is working very smoothly. Okay, so I will discuss here about the perpetual motion machine of the second kind. So the machine which violates the second law is called the perpetual motion machine of the second kind. Here we can see that there is a machine. Let us assume an engine take heat QH. Here it is a source TH. From here it takes the heat QH from the source. Does work W. It taken out W and releases heat QL to the sink TL. Now assume that another device which take heats QL prime from the sink and take some work from the heat engine here from the engine and delivers heat QH prime to the source as shown in this diagram. Okay, this you can see. This is the source here. This is the sink here. Okay, so here we have one. Assume that there is a source with temperature TH. From here, you are taking the QH from here and you are releasing heat QL from this. The work done is QH minus QL. W is equal to QH minus QL. This is the first law of thermodynamics. Now, we take some part of this work and we are putting in this in a heat pump. This is the heat pump. I am writing HP. So this work of the heat pump is to extract energy from the low temperature zone. So assume that Q prime L it is extracting from here. Then it goes to the extracting from here and it goes to here. So Q prime L and Q prime H it is releasing from here. Whether it is possible or not, that we have to see. As per looking, it is looking like yes, it is possible. But in fact, it is violating the second law of thermodynamics. So we will see here that QH minus QH prime is greater than 0. Then only it is possible. Now QL is also QL minus QL prime is also greater than 0. Because if this is higher than this, then only it will go that side. Now W minus W prime is greater than 0, as W prime is part of W. Because we have taken some part here, so this is the another equation. Now we can see here that QH, W is what? QH minus QL. W is QH minus QL is greater than Q prime H minus Q prime L. Okay, so this we can see here that W minus W prime is greater than 0. So we can see this W is equal to what? It is a QH minus QL is greater than Q prime H minus Q prime L. So we can write here QH minus Q prime H is greater than QL minus Q prime L. So we can see that this is 0 greater than 0. So QL is less than QL prime. So this is not possible. So this is perpetual motion machine of second kind, as it violates second law of thermodynamics. Okay, so that is why it is called the perpetual motion machine. By seeing the picture, you can see that image here that it is possible. But in the real, it is not possible. In olden days, 100 years back, so many people used to publish some literature that I can make the engine by running by water, running by without any energy, this will that thing, that thing. This is not possible. This is all are the fake people. Don't just believe like that. So in this we will see that if QL is equal to QL prime, then no heat exchange between QL and QL prime due to the same reservoir, because QL and QL are same. Moral of this is, do not try to run the perpetual motion machine. This is the moral of this thing, that do not try the machine like a perpetual motion machine, as I have shown here just now. Now we will discuss again the same way something perpetual thing, and this is the Maxwell Demons and how these things are happening. Here we can see that there is a box. The objective of is to separate high and low temperature molecules in this box. So it represents as a binary system, a demon sitting at the gate, which is frictionless. Demon is like a gatekeeper. The high temperature molecules have the red tag here. This you can see in this box. All the red are the high temperature molecules, and the low temperature molecules are having the blue tag here, blue dot and the red dot. So our objective is how we can separate the high temperature molecules and the low temperature molecules separately. So this is the concept of the Maxwell Demon. It is also related to the second law of thermodynamics, that something is not possible. Like perpetual motion machine, here also in fact it is not possible. But so after some time, a high temperature molecules in the right box and the low temperature molecules in the left box separated. This you can see this second diagram here, and this is the first diagram. So paradox can be resolved. How demon know that these are the high temperature and these are the low temperature, red one? So this can be, demon may have the memory to recognize fast or the slow moving molecules. So we have given some condition that those who have this much temperature and those are having this much temperature molecules to be separated. So as per the temperature of your molecules, their speed will be also different. So this demon will have some logic, some robot type of thinking. It is programmed. It will assess it, and slowly when the red is coming, it will allow this direction, and when the blue is coming, it will allow in this direction. So every time memory is acceptable. To get something, you need to put some effort. So this is not without doing some work. This demon has to do some work. If it is robo also, it is operated by some electrical, it is having some sensors. By that sensor, it will work, and slowly, it will make sure that these things are, red is here and the blue is in this direction. All blue are the red. This is the high temperature zone. High temperature molecules. And this is the low temperature molecules. Okay, so like this we can do it. We can make some, and this assumption, it is also a fiction. It is not the real things. A concept was given by the Maxwell, and he has given this person as a demon. This demon is like a robo. It will only open the gate for the red molecules to go in the left side, and whenever the blue will come, it will open to go in this side. And slowly after some time, red is separated and the blue is separated. So like this, it gives some concept of the second law of thermodynamics. Now we will discuss about the reversible processes. So what is the reversible processes? In thermodynamics, reversible processes which will give the best efficiency. So we have to discuss about reversible processes. All our engines, your gas turbines, these are supposed to work as a reversible cycle. Then only we are going to get the best efficiency. And we know that efficiency is the work output divided by total input which we have given. So out of given quantity, how much percentage we are going to get the useful work. That is called the efficiency. So reversible process. A reversible process is a process which once having taken place can be reversed, and in doing so leave no net change in the system and surrounding. Okay, so if you move from one object from one place to another, and it is coming back from there to the original place, it should come back, but there is no change in the system and surrounding. Your system and the surrounding, there should not be any change. That is the definition of the reversible cycle. Let us say a block diagram sitting on a ground at state 1 and move to another state 2. When moving from state 1 to state 2, there is a friction between block and the ground. While moving from 2 to 1 direction, opposite, but friction will be in the same direction. Block came to the same location, but heated due to the friction, so heat Q to be removed. So the surrounding state is not in the same state. So the friction makes the process irreversible. So here, this we can see here, this is the ground. Here is a block at state 1. This has moved from here to state 2. Okay, in this direction. Now, as it is moved from here to here, due to this block and this ground, there is a friction. Some energy is taken, and again, you are moving from here to here. This again has come in this. Actually, this has come, but this is having from here to here some heat energy is released, and from here this heat energy 2 heat energy is there. So in this time we have here object has returned, but it is not in the reversible because it is extra heat. So you have to remove this 2He. You have to remove. So this system is reversible, but your surrounding is not in the same state. System is so this your surrounding, your atmosphere has got some additional heat. That heat make the system irreversible. So this is the process of the reversible, means the system and surrounding both should be reversible. In this case, the system is reversible, but total system and the surrounding is not the reversible. So like this system is not the reversible processes. So here, what type of process can be approximated as a reversible process? So here I want to discuss about figure 1 and the figure 2 here. So in the figure 1, gas is filled with a pressure and locked by a pin. If pin is removed, piston will hit the stop. Work is done from 1 to 2. Now 2 to 1 need more work due to high pressure generated by the stop than 1 to 2. Process system more heated, Q out goes to the surrounding, so it is irreversible process. So just you can see here that here is a piston, here is cylinder, here you have the high pressure here, there is a pin, you remove this pin, then what will happen? This pressure will force this thing to come from state 1 to state 2. But here is a stop. This stop makes that the pressure is increased. To increase this pressure, we have to put some more weight on top of this, and slowly we have to remove it. So after this, it has to come down. It means what? We need more force to put down because it is generated high pressure. So this, when it is reaching here, this has got more energy, more heat. This heat has to be relieved like this. This heat has to be released. So if you release this heat, your system is in same state, but surrounding is not in that, because the surrounding has got some additional heat. So this is not a reversible process, it is a irreversible process. So how we can make the system reversible? So to make the system reversible, as I have discussed in earlier also for equilibrium, here we have reached in this state. Here you put some weight of small sizes. Slowly you remove one by one, very slow process. We need to put large number of thin slice of load. Remove one slice at a time. So piston will move little downwards slowly. When removed all it will reach to the top. Now we have to put back one by one load. So there will not be any change in the system and the surrounding and both. So it's due to the slow process, reversibly process happened. It is quasi-equilibrium condition. So this I can again write here. So we have the stop here. You have one piston here. Here is the gas. You put some weight and very small slice. So many slices are here. You remove one, it will move here. You remove one. So it is moving like this. Okay. So this is the state 1 and this is the state 2. So at this state, assume it is a 100 slices are there. Okay, 100 slices. If you remove one slice, then 99, it will be here. It will be here, 98, 99, 99, 99. Okay, like this. Like when you reach here, you will not have any weight here. So it will reach here. Now you want to do again. You put one more slice here, one more slice. So it will go in the same points. It will go like this. When you put the 100, it will again reach to its equilibrium position. That type of situation is called the reversible process. Here, no heat is gained by the surrounding, and the state 1, what was the before, it is in the same state. Like this, we can achieve the reversible process. Now I am going to discuss about the factors which are affecting the irreversibility. So here one is the friction, second one is the free or unrestrained expansion, mixing of the gases, hysteresis, eddy current losses, heat transfer across finite temperature difference. So here these factors we can divide into two groups. One is the internal reversible, another is the external reversible. Internal reversible means if it is going and coming back, the system is in the same state, then it is internal. If the system and the surrounding both are in the same state, then it is a internal total reversible. So here first we will discuss about the friction. This I have already explained you that this is the block here. This block is moving from state 1 to state 2. During the motion on the ground, it has some friction. This friction will generate some heat. So from state 1 to state 2, the system has some additional plus heat. Now, if you are moving from here to here, again you reach here, but you have the double heat. 2 plus I am putting. Initially it was 0 heat here. But when you again return, you have this 2 plus you have. This you have reached, but it is not a reversible process. You may feel that you have reached in the same position, but in the real sense, you are not in the same position, but this has got some additional heat inside. So system is irreversible. So this is due to the friction. Second, I am going to discuss about the free or unrestrained expansion. So if you have the free and unrestrained expansion, just you can see here work is not done. This gas is filled here and here is a vacuum. So if you are expanding in vacuum, there is no work is not done. So you are expanding here, you open this valve and this gas is filled here, no work is done. Now volume is reached from here to here. Now if you press it from this valve, it will again come to this position. By coming this position, you reach here, but this will not be in the same state as it was in 1. This will have some plus or double plus because expansion and this thing, again this will have some additional heat. So this is also irreversible process. So your free or unrestrained expansion is also irreversible processes. Then mixing of gases. Here if you see the gas 1 and the gas 2. These gas 1 and the gas 2 are having different pressure, different temperature. If you mix this both, and I have given you the one Maxwell Demon, and use this Maxwell Demon and again you separate gas 1 and gas 2, you will see that there is imbalance of energy. In both sides, there will be some additional energy. Not this. Energy, additional heat is generated. That heat will give you the irreversibility. Fourth one is the hysteresis or eddy current losses due to the electromagnetic effect. It will not go in the same path. If you go and reverse, the path will be different. So these 4 items, 1, 2, 3, 4, they are the internal reversibility. And the fifth one is the heat transfer across finite temperature difference. So if you, here this TH is greater than the TL and this will happen spontaneously. It is a natural phenomenon. But if you want to make from TL to TH, it is not, you need to do some work. So heat transfer with a finite difference, if you want to do, Q dot is directly proportional to area into delta T. If delta T is 0, then area you need infinite. Means if you want to make a reversible process, very huge area, miles of area is required. That much space we don't have for any of the system. So this is also limitation of the any of the system. So these are the 5 important factors. Those factors are making the system irreversible. There is a friction, free or unrestrained expansion, mixing of the gases, hysteresis or eddy current losses, heat transfer across finite temperature difference. So this we have to always remember these 5 points, because these 5 points are making the system non-ideal conditions. So the next topic I am going to discuss about Carnot cycle, an example of reversible cycle. Carnot cycle for the control volume or the flow system, and Carnot theorem. This I am going to discuss because the second law of thermodynamics says that a 100% efficient engine is not possible. Means whatever you give the energy, same amount of work is not possible, or you give some work, the same amount of heat cannot be delivered. There will be some losses, and how much you can get. The Carnot has given the reversible cycles. In this we have the 2 reversible adiabatic cycle and 2 reversible isothermal or isentropic processes. So we will be seeing in our next class how we are going to describe these all cycles. These are the references which I have taken from P.K. Nog, Engineering Thermodynamics, Tata McGraw-Hill's 4th edition, Eunice Sengel, Michael A. Bowles, Thermodynamics and Engineering Approach, Tata McGraw-Hill's. Then this is the NPTEL lecture from Engineering Thermodynamics by Dr. Mishra, IIT Kanpur lecture. Please visit this site and see a very nice lecture by the Professor Mishra and also Professor Sumant from IIT Kharagpur. Very nice lectures on concept of thermodynamics. This will be very useful for you all. Any questions, you are welcome to ask me. I will be very happy if you are responding me in my this mail, ydvedi@gmail.com. You also like and subscribe this channel and give the comment in comment box so that I can see that and I can respond. If I might have done some mistakes during my lecture, that I can correct in my lectures. I can modify the lecture as and when I get some feedback. Thank you very much. Always, we will see in our next lecture about Carnot cycle. Till then, goodbye. See you.
Like, share and subscribe. Hit the bell icon for more updates.